Hi everyone. In the previous lesson, we have learned how to find first derivative. Next, we will go into second derivative, and also we will look at the application of differentiation. So today, we will focus on incremental formula. Okay, and so we will look at how we derive this formula and how we can apply this formula. First of all, we will see how increments formula is derived, and after that, we will learn how to use increments formula to find small change. So in this diagram, we have point A and also point B. So if we connect A and B, we have a secant line AB. So this is the secant line. Now, I imagine point B is getting closer and closer to point A, okay, such that h is almost 0. Okay, then the gradient of the secant line AB, okay, will be approaching the gradient of tangent at point A, okay, which is also equals to the gradient of the curve at point A. So we define the gradient of the curve at point A, yeah, as the gradient of the tangent that passes through point A as the limit of f of x plus h minus f of x divided by h as h approaching 0. And this is also given by gradient function, and we normally we write it as f prime x or dy dx. We know that the numerator, okay, which is this part, is the change in y, and this h is the change in x. If the change in y and the change in x is small, so we can actually write the dy dx as the limit of delta y over delta x as delta x approaching 0, okay, whereby delta y is the small change in y and the delta x is the small change in x. So if the change in y and the change in x is small, so as you can see in this diagram, okay, the gradient of the secant line AB is almost the same as the gradient of the curve at point A. So if the change in the y and x is small, so we can say dy by dx is approximate equals to delta y over delta x. dy dx is the gradient at a particular point. Delta y over delta x is the gradient of the line segment as the 2 points are very close to each other. By rearranging it, we now have delta y approximately equals to dy over dx times delta x, and this is what we call the increment formula. So the increment formula actually help us to determine the approximation for the small change in one variable when a small change in a related variable is given. For example, if the small change in x is given, then we can find the small change in y, or it can be the other way around. Next, we will explore a few examples so that we can see the increments formula in action. So in this example, it is given y equals to 3x cubed plus 2x minus 1. So we are supposed to find the approximate change in y when x changes from 2 to 2.01. So we know that we are supposed to find small change in y, and we can use delta y to represent small change in y. Okay, and we know that the original x value is 2 and now the new x value is 2.01, so x increases by 0.01, so we can say delta x equals to 0.01. Okay, and we know that incremental formula says delta y is approximately equals to dy by dx times delta x. Okay, and based on the original equations, yeah, we can differentiate y with respect to x. So we get dy dx equals to 9x squared plus 2. Okay, and taking the increments formula again, okay, we now substitute the dy by dx and also the delta x, which is 0.01, inside the increments formula. Okay, of course, we also need to substitute x equals to 2. So, okay, so now we can calculate delta y, and we get delta y equals to 0.38. Okay, of course, we can actually work out the exact change in y when x changes from 2 to 2.01. So how can we do that? Okay, it is very easy. So we substitute x equals to 2 in the equation. So we get y equals to 27. And when x is 2.01, we get y is equals to 27.381803. This one we need to use calculator. Okay, now, okay, what is the difference? Or what is the exact change in y? So the exact change in y when x changes from 2 to 2.01 is actually 27.381803 minus 27. So we get a difference of 0.381803. And if you compare the exact change in y with the estimated change in y, which is 0.38, so we can see that this is actually accurate enough because we don't have to use calculator. Okay, of course we don't have to work this out. Okay, this section is just for you to see the difference, yeah, between the exact change in the y with the estimated uh, change in y. In example 2, we need to find approximate change in the area of a square when the side decrease from 20 cm to 19.75 cm. Okay, so we have a square here. So with the side x cm. Okay, according to the question, we need to find approximate change in the area. So if A represent area, so we need to find delta A. Okay, and according to the question, we know that sides decrease. So then that means the small change in the x will be negative 0.25. Okay, so since we want to find delta A and we know delta x, so we need to have a relationship between the A and the x, area and the relationship between the area and the side. Okay, so we know that A is equals to x squared. So by differentiating the A with respect to x, we get dA dx equals to 2x. And so by taking the increments formula, so increment formula say delta A is approximately equals to dA by dx times delta x. So we need to substitute the dA dx and the delta x in the increments formula. Of course, we also need to substitute the original x value, which is 20, in the formula. So we can get delta A equals to negative 10 cm cubed. So that's mean we found that the approximate change in the area is negative 10. That means the area actually decreases. So now we can actually find out the exact change in the area. So to make life easier, you can use calculator to help us. So we just need to use the new area, which is 19.75 square, minus the original area, which is 20 square, and you get a the exact change in the area of negative 9.9375 cm cubed. Okay, so if you compare this value with this value that you calculated just now, we can actually say that this value negative 10 is actually accurate enough, and we don't have to use calculator. Yeah, so of course we are not required to find the exact change in the area. Yeah, we just need to find the approximate change in area. So so this answer will actually be sufficient. In example number 3, we need to differentiate square root of x with respect to x and use the result to find the approximate value for square root 24. So what do we actually need to find now in these questions? Okay, we are supposed to find the approximate value for square root 24. Okay, so first of all, we need to find a close easy value. Okay, so look at square root 24. The closest easy value is square root 25 because 25 is a perfect square and square root 25 is equals to 5. Okay, so now if y is equals to square root of x, so that means now we are trying to find a new y when x changes from 25 to 24. Okay, so we have the original x value, which is 25. Then we know that the x changes from 25 to 24. Then that means we have a delta x of -1. And then the original y value is square root 25, which is equivalent to 5. And the new y value is square root 24. Yeah, and we are supposed to find the approximate value for square root 24 here. Okay, so before we proceed, we need to know that the new y is equivalent to the original y plus the small change in y. So the next few steps actually enable us to find the small change in y. Okay, so first of all, we write square root of x as a power. So we have y equals to x to the power of 1 over 2. Then we differentiate y with respect to x. So with that, we have dy dx. And now we can apply the increments formula. Okay, so we substitute dy by dx and also the delta x in the increments formula. So we can see that the delta y is negative 0.1. Okay, so next, okay, then now we need to find the new y, which is square root 24, and we know that the new y is original y plus the small change in y. So by doing the calculations, we know that square root 24 is approximately equals to 4.9. Okay, so you may now check answer by using a calculator. So we can press a calculator, find square root 24 and see whether this value is close enough to the value given by the calculator. Okay, you will realize that this value is actually accurate enough, and you don't even need to use a calculator. Next, we would like to discuss about small percentage change. Earlier on, we were discussing about small change, and now we would like to talk about small percentage change. So there is a word percentage here. Okay, so in this example number 4, okay, it is given that v is equal to 2x cubed, and we need to use differentiation to find the approximate percentage change in v when x changes by 2%. So before we proceed, I would like to point out one common mistake often made by students. Okay, so the common mistake is students used to write delta x is equals to 2%, which is 0.02. Okay, but this is not the correct way to write it because x changes by 2% does not mean that delta x is actually 0.02 units. Okay, then what is the right way to write? Okay, so we know that delta x is actually 2% of the original x. Okay, so by rearranging the equation, we have delta x over x equals to 2 over 100 or 2%. Okay, so this is the right way to express delta x over x or the percentage change in x. Okay, so we go back to this question again. So we are supposed to find approximate percentage change in v. That means we are supposed to find delta v over v. Okay, so based on the equation given, if we differentiate the v with respect to x, we will get dv dx equals to 6x squared. Okay, so now first of all, okay, we would like to find out what is delta V. Okay, so by using the increments formula, tells us that delta V is approximately equals to dV dx times delta x. Okay, so I substitute the dV dx in the equations. Okay, since we actually wanted to find delta V over V, okay, so what I can do now is I divide left hand side and the right hand side with V. So I divide both sides with V. Okay, so but then the V is actually equals to 2x cubed. So now I have delta V over V equals to 6x squared times delta x divided by 2x cubed. Okay, so now we can do the simplification. Okay, so x squared and the x cubed, you simplify, you have 1x left down here, and 6 divided by 2, you have 3 left. Okay, so after the simplification, we have delta V over V equals to 3 times delta x over x. Okay, and now we can substitute delta x over x, which is 2% or 2 over 100. Okay, so at the end, we have delta V over V equals to 6 over 100 or 6%. Okay, so at the end, we can say there is a change of 6% in V.